Hi, this is problem 12 from the 2018 AMC 10A. How many ordered pairs of real numbers x, y satisfy the following system of equations? Okay, so this first equation is just a straight line, so we know how to handle that. But the second equation contains some nasty nested absolute value signs, which looks a bit scary. So I think we'll have to use symmetry to help us out with this second equation. So let's see what that looks like if graphed on the xy plane. So let's draw this carefully. Make 3 tick marks along each axis. And when we look at the second equation, we notice that when we substitute x for minus x, the equation is unchanged. So that means that the graph for this equation is symmetric around the y-axis. If we exchange y for minus y, the equation is unchanged. So this graph is also symmetric about the x-axis. And we can also swap x for y and leave this equation unchanged. So we know that the graph is also symmetric about the 45-degree line. So that's quite a bit of symmetry. And what that means is we can choose any of these regions which is most convenient to analyze this equation. And for my money, I think this region is probably the easiest to analyze, because in that region we know that y is always greater than x. So let's analyze the second equation in this shaded region. And given this constraint, we find that this equation with the absolute value signs reduces to y minus x is equal to 1, or y is equal to x plus 1. And that's pretty simple to graph. This line just looks like this line segment in our chosen region. Now with this information, we can use the symmetry operations to fill out the rest of the graph. So let's go ahead and do that. So if we reflect this line around the 45-degree line, we get this line segment. And if we reflect these two lines around the y and the x-axis, we can fill out the rest of this graph to look something like this. Okay, that looks pretty good. So now let's go back to our first equation, x plus 3y is equal to 3, and see what that looks like. So when x is equal to 0, y is equal to 1. And when y is equal to 0, x is equal to 3. So that first equation generates a straight line that looks like this, and that intercepts the second equation in 1, 2, 3 points and no others. So that gives us answer C, 3.